we are Alejandro, Fernando, and Nicole from Group 5, and we're going to solve 3 calculus problems. The first one is problem number 4, which we have to evaluate this limit at infinity using the analytical method. So, first, we check which exponent is bigger, which is this one, to the square. So, we have to divide the fraction, the denominator and numerator by x to the square. So we get 1 divided by x squared dividing x squared divided by x squared. So we get 5 minus 1 dividing x divided by x squared divided by 1, which is equal to 5 minus 1 divided by x squared. Then we have to substitute the x by infinite. So we get 5 minus 1 divided by infinity to the square. By some rules, we'll learn that infinity to every exponent is equal to infinity. So we get 5 minus 1 divided by infinite. We learned that every number divided by infinity is equal to 0. So we get 5 minus 0, which is equal to 5. And this is the answer.
So our next problem is problem 43. We have our equation and we need to tell if at the point where x value is minus 3, if it is continuous or not. So first we need to get our asymptotes. And our asymptote is where the same point, so we can conclude that at this point of the graph does not exist. Because we need to remember that any part of the graph can touch our asymptotes.
For our last problem, we have problem number 14, and it shows us a graph with 2 lines graph, 2 dots open, and a little dot closed. We have to find the option that tells us that the graph is a discontinuous graph. The first option says f of 1 equals to minus 4, but this is false because in f of 1 we don't have a minus 4, so that is false. The b says that in the limit f of x equals to 2, but we don't have any closed dots, so that we know that it's false. In the last option, it says that in f of 2 the graph does not exist, but we have a little closed dot, so we also know that this is false. So we have the option C that says when the limit f of x approaches to 2 does not exist, and this is true because there is no graph approaching to 2.